Hello Year 10 and welcome to our third lesson on coasts. Today we're going to look at how sediment, which is sand, is transported, which means moved along a beach. So how sand is moved along a beach. Before we do that, what I need you to do is a few things for me. I'd like you to write your lesson title, which is the question at the top, how is sediment transported along a beach? We'll aim to answer that question by the end of the lesson. I need you to write your keywords. That's the three of those there: longshore drift, prevailing wind and groin. And I need you to complete the do now and the stretch task, which recalls the information that we learned last lesson about constructive and destructive waves. You may want to pause this video while you write those down and then press play to continue. Okay, so in terms of our do now, the first one, swash, is the movement of wave up the beach. That's towards the land. That is true. And if we look at this diagram here, you can see the blue is the sea. The wave coming up to the beach is called the swash, moving forward. Question 2, backwash is the movement of a wave away from a beach. That is true as well, back into the sea. And if you look at the diagram, you can see the backwash arrow here is the backwards movement of a wave away from the sea. Actually, it would be in the sea there, moving backwards. And then the stretch question, what type of wave causes a beach to erode? Remember that erode is the wearing away, apologies for my writing there, of material where it is taken somewhere else. So in this case, the beach sand being taken away. And it is a destructive wave. Destructive, easy to remember because it destroys the beach, destructive. And that is a wave with a strong backwash, taking the material backwards away from the beach. Okay, if you're not sure of that, do revisit the last lesson or revisit this explanation here. Okay, to focus. How is sediment transported along a beach? This is a question that the exam board will want to ask you. You can see on the left here from the specification content from AQA that down here is where it references transport and longshore drift. So two words we need to pull apart today: the movement by this process of longshore drift. There's 3 keywords we're going to use in this lesson, and we will do some writing at the end using these words. I'd like you to repeat them after me, please. Don't worry if there's someone else in the room listening. They're going to learn what these words are and maybe ask you about them later, which will be great. Okay, so the first word, repeat after me: longshore drift. Longshore drift. The second word is prevailing wind. Prevailing wind. And the third word is groin. Groin, spelt with a Y there. Okay, so let's look at this picture of a coastline. You can see the sea on the left, the beach on the right, and if you've got great eyes, you can see a road there. All the sand on this beach is actually moving sideways in a zigzag sort of fashion along the beach. Sand moves along the beach. So if you look at my red dot here, if there's a piece of sand here, over time it moves all the way down there. And you might think that's not very interesting, but actually it's really, really important, because if the sand on a beach moves and disappears, we've got a problem because we've got no beach left. So we're going to look at why is the sand moving along a beach, and that is what is called longshore drift. So I guess it's movement along the shore, shore being the coastline, long meaning moving along the beach. Longshore drift is the movement of sediment, sand, along a coastline. Okay, I'm going to explain with this diagram how it happens, and then we'll break it down into smaller pieces to make sure we have a clear understanding. So the first thing that happens is the swash, that is that wave moving towards the beach, carries material to the beach at an angle. And if you look at this arrow here, as the wave moves to the beach, it's at an angle. It's not in a straight line, it's in an angle, and that is because wind usually blows in one direction. Some days it changes, but most days the wind blows in one direction, and that is what we call the prevailing wind. So the swash carries sediment and sand along to the beach at an angle due to the prevailing wind. Then, if we look at this, there's the sand here, it's been carried up there. It goes back into the sea, but this time in a straight line. And that's because gravity pulls the backwash, pulls it down really fast. Underneath the water, very underneath the sea, near the seabed, the sand is pulled backwards. And if you were to stand in the sea, you would feel the wave moving towards you at an angle, the water swishing against your feet, if you imagine that. And then you would feel the wave pulling back out into the sea below you. That's the backwash. And it goes in a straight line back into the sea. That repeats. So the sediment is then moved again by the prevailing wind and brought backwards by the backwash due to gravity. And this carries on along a coastline, moving the sediment all along in something called a zigzag fashion. The zigzag is this kind of shape. And the only thing that stops that happening would be like a big barrier to stop the sand. And a barrier is what we call a groin. Groins trap the movement of sediment. And you can see that as the sand is moving, there's more sand here because it's being built up, it's being collected. Okay, so this is the overall movement. So what I'm going to do, I'm going to try and draw this for you. I've got my beach in yellow at the top and my sea at the bottom. So some sediment will start, a piece of sand is floating in the sea, and it will travel up to the beach by the swash. And that is at an angle. Do you remember what is taking it at an angle? It is that prevailing wind. So it is the prevailing wind that takes it up at an angle. And now I've got sediment on the beach, piece of sand. That piece of sand travels back into the sea by the backwash, and that is due to gravity. Gravity pulls that backwash back into the sea, and my piece of sediment, which started up over there, is now over here. That continues at an angle. Why? Because the wind blows the swash at an angle. That's my swash, and my sediment is here, and it is then pulled backwards by gravity in a straight line. And over time, that moves along in a zigzag fashion until something stops it. Now, in my diagram, there is nothing there to stop it, but if I drew a big wall, a barrier called a groin, G-R-O-Y-N-E, that would stop my sand going any further. So this movement along a coastline of sand is called longshore drift. Okay, so down here we've got a definition. Sediment is transported along a beach in a zigzag fashion due to the swash and backwash. And remember, the swash is at an angle due to prevailing wind, and the backwash in a straight line due to gravity. You may want to pause just to read through this. Okay, let's see how much we've understood so far. So questions. What is the name of a wave moving towards a beach? Just want you to think what your answer is, and I will reveal an answer in a few seconds. What is the name of a wave moving towards a beach? Don't be shy to say it out loud. Okay, you should have the swash. Swash is when a wave moves towards the beach. Next question. What are most waves carrying? What do most waves carry? This is the material that is moved, and it is the sediment or sand. Sand is fine. Sediment is a much better vocabulary. It refers to any sort of particles really that's in the water, but sediment or sand is what moves along, moves up by the swash and back by the backwash. Question 3. Why, okay, that's written wrong. Why does the swash travel at an angle? And I'm going to change that question. Why does the swash travel at an angle? There, fixing my literacy of that sentence. Why does the swash travel at an angle? Because of the prevailing wind. That is the wind that is mostly blown in that direction. Why does the backwash then retreat back into the sea in a straight line. Okay, this is gravity that brings it back in a straight line. And what kind of pattern is the sediment transported along the beach? In a zigzag pattern. Okay, so now what we're going to do is try and practice this together. You can see there, I've got a groin actually trapping some sand. Lots of beaches have these great big wooden structures. If you see those, that is a groin. It's a wooden structure that is there to stop that sand and sediment being moved along. Okay, let's practice. So on your paper, I would like you to draw with me, please, what is happening. So let's draw a piece of sediment. So I've got a piece of sediment there, you've drawn that. And let's think how that moves to the beach. Does it move at an angle or a straight line? It moves at an angle. And that movement, is it the backwash or swash? It's the swash. At an angle due to the prevailing wind. Okay, make sure your diagram looks like mine. That piece of sediment then moves backwards. So draw your backwards line, please. And that is the backwash. Okay, I need to redraw my line. There we go, backwash. And that carries on like this. So you should be drawing something like what I have. I'm going to add on to that the reasons why. So it moves at an angle because of the wind, and the backwash moves due to gravity down there. Okay, so that is longshore drift. Okay, so your diagram should look something like that. Okay, so what I'd now like you to do is, using our keywords, answer the question, how is sediment transported along a beach? That should be one word. I'm going to rewrite that, along a beach. How is sediment transported along a beach? How does it move along? That could be a 6-mark exam question, but it is the question of our lesson today. In the answer, you would really want to use 3 words there somewhere in your answer. I might want to start by saying what happens first. So look at the success criteria here. What happens first? So think about that sediment. It moves along the beach at an angle, you would say, but why is it at an angle? Then what movement happens next? What movement happens next, and why does it happen? Over time, how is this movement moved along the beach, and what might cause it to stop? Okay, so that is your answer. You'll see in the comment below this video link, there is a link to a form where you can write your answer to this question, put your name in and your learning family, and you will be able to submit your answer to that question and get some feedback from your teacher. So please do that by clicking the link below. Hope you've understood this. If not, you can repeat and try again. BBC Bite-Size Geography has some great resources on longshore drift as well. Links in the comments below. And good luck.